Alright, hello and welcome to my presentation on SQL injection attacks by Taylor Johnson, which is my name. Now this presentation is for my ICS 382 Section 1 Computer Security class with my professor, Sue Fitzgerald. Let's begin. Now I must provide a disclaimer. This presentation is purely for educational purposes, and I'm not liable for any damages that could be caused by this video or anything that may be demonstrated from within. Anyways, what I'm really trying to say is, don't use SQL injection on stuff you don't own. Don't do it. It's illegal. Alright, the purpose of this video is, well, more like I'm going to describe SQL and SQL injection, kind of the obvious point of this, provide a brief history of SQL injection, a brief, somewhat brief demonstration of SQL injection, a legal demonstration of SQL injection, I should specify, and how to protect against SQL injection. Because what is the point of cybersecurity if I don't tell you how to protect against it? Especially against SQL injection. Probably one of the oldest cybersecurity things out there. So first of all, what is SQL? SQL, also known as SQL, stands for Structured Query Language. It is the programming language used to communicate with databases. It is the primary language of relational databases specifically. So databases used by Microsoft, Oracle, Ingress, etc. So it's pretty much the de facto database programming language out there. Now, this I'm going to just go over briefly of what SQL looks like, because this is not, well, a presentation on how to do SQL, it's a presentation on SQL injection. So I'm just going to describe this rather briefly. So right down below you'll see a table, specifically, well, just a table, it doesn't really matter what its name is. It has, okay, I guess it does matter. You know what? Cut that. Alright, this is what SQL looks like. This is going to be brief, so I'll just be brief. So right down below you'll see a table. I'm going to call it users table, and it has 4 columns in it. The first one is ID, the second one's name, third one's email, fourth one's password. You know, this table means really nothing, it's just as an example. So each column has some restrictions to it. So the ID table can only have integers in it. The name table is essentially a string. Password, probably also a string or something like that. Data types do play a big part in SQL, but that's for another time, and that is neither here nor there. So, SQL looks like this. Let's start with the from, because that's probably the easiest to start with. From, in a SQL query, always comes second, and it is used to describe what table are you specifying. So from users means I'm specifying from the users table, to put it in a more syntactically relevant way. Now let's go to the first one, select. Select is the key phrase in SQL, and after it you put in the name of the column names. Or you can put star in, which is essentially gets all of the column names. It's kind of a wild card in that sense. So select star from users, if that was only it, you would just get everything from the users table. That's it. Now for the third part. Select star from users where ID equals 5. I'll be honest, I think it's fairly straightforward, but it's only going to get the record where ID equals 5. It's essentially a conditional statement, in a way, I guess. So, the result of this SQL statement is going to be the one at the bottom. It's going to return 5, John Smith, joetest@test.com, John Smith. And that's essentially what SQL looks like in the most basic form. Now, what is SQL injection? Well, it stands for Structured Query Language Injection, or as I just said, SQL injection. And it is an attack on a database through a website. Typically through text fields. In the case of, well, as an example, a username or password text field. So, what does SQL injection look like? Well, it looks a lot like, well, to put it simply, SQL code within a text field. That is the most basic form of SQL injection. Let's say you have this. You have select star from users where name equals John. That's what you want to have on a website, essentially. And you don't know a lot about, integrating SQL with Java or PHP or whatever. So in those languages, you essentially have to build the SQL statement. So the statement would look like something you'd see on the second line. It would be this variable statement equals everything within the two quotation marks, select star from users where name equals, and then essentially you concatenate input from text box, and then you end concatenate it. The specific things to note is that the before and after the concatenation of input from text box, you'll notice two things. Well, one thing specifically, I guess. It is the input from the text box is supposed to be a string, because, well, it's a name. Names are usually strings. So in this case, to specify strings, you would use single quotation marks. One at the end, one at the beginning. So, I'm going to go over very briefly and just describe this is an insanely bad idea. This is what makes a SQL injection impossible. But anyways, let's go on. So, input from text box. You have a text box. You want to put a SQL injection in it because, hey, you're a hacker. That's what you do. This is what you put in. Single quotation mark or 1 equals 1. Specifically the exact same thing down there. So, to put it in perspective, this is what it looks like now. Statement equals select star from users where name equals in concatenation or 1 equals 1. Or to put it actually all together now to make it more understandable is the final line where it says select star from users where name equals nothing or 1 equals 1. Now, to describe briefly what happens here is essentially name equals nothing or 1 equals 1. Well, it's an OR statement, so only one of them have to be true. Since 1 equals itself, that returns true. So now it's select star from users where true. That doesn't really make sense, does it? Well, at that point, since it's a Boolean that returns true in a conditional statement, you can just essentially ignore the where statement. It's now select star from users. Congratulations, you just returned every single record from the users table. Now, that users table has, say, addresses, names, passwords, social security numbers. Whew, well, I have nothing really more to say besides that is really bad. Now, SQL injection. How long has it been around? Where has it come from? The answer is, well, it's this, essentially. SQL injection was first documented by Jeff Forrestal, also known as Rainforest Puppy was his moniker back in the day, in 1988 in the hacker magazine Frack. Essentially, he described his conversation with Microsoft dismissing the possible threat and as something not to worry about. As I just described and demonstrated, in a way, it is definitely something to worry about, and, well, simply put, 20 years after it's been first documented, SQL injection and injection attacks in general are one of the top threats, if not the top threat, on the internet. The reason for this is because I just showed it to you. It's incredibly straightforward and simple. And it is surprisingly easy to, well, not defend against, I guess. Now, on for a demonstration. Hello and welcome to the SQL injection demonstration using WebGoat, which you are able to freely download, well, just by typing in WebGoat. I can't quite remember what the website is called, but you'll find it easily enough. Now, starts off easily enough. You just need to essentially just run it from the command line, and you can just, get to WebGoat by going to, your local host and going to WebGoat, and it will direct you to the login. You actually have to make a new user, and you type in whatever it is. Alright, now you can do all sorts of penetration testing right here, right now, but we'll just be focusing on injection flaws, specifically SQL injection. Now the check mark means I've done everything here. Now, you essentially learn about SQL injection right here. It assumes that you kind of know a thing or two about SQL, but nothing about actual injection. Now let's go straight into the actual, let's go with number 8, because I believe number 8 is actually a bit easier. So here we have the text field, the prime location for all SQL injection, because you have to type stuff to actually do SQL injection somewhere, usually a text field or a URL occasionally. Now right here, if we click the button with nothing in it, it says sorry, nothing's in there. Unexpected end of statement. The fact that it's actually returning this means that the site itself is really insecure. How insecure? Incredibly insecure. Insecure enough. Insecure so far that I'm able to hack it. Now, the question is, what do we put in it? Now if we type in, say, 548, nothing. No match results. But it tells you if you type in 101, well, you actually get something back. But that's not what we want to do. We don't actually want to be legitimate. We want to get every number, every user ID, every account information in there. How do we do that? SQL injection, of course. Why else over here? Now, we start off with the simple. 100. Nothing in there. Now, the number you put in doesn't really matter. We could actually have used 101. But let's just use 100 since I like it. Now, the fact that it actually says unexpected end statement in there means we can hack it easily enough. Let's just type in 100, put in our little conditional statement of OR, and what equals true all the time? Well, we could just type in true, or we can do 1 equals 1. Now, this may seem simple, and it is, but it will work. See? We've got everything. And now, just for testing purposes, let's type in 100 or true. That also works. Because, it didn't return an error, and it's the same thing. So you can also just type in true if you want, right there. Surprisingly works. Now, let's do something which is a modicum a little bit harder, and that is because it actually uses, quotation marks. Single quote and double quotes. Now right up here we're given the actual SQL query being run. Ignore this stuff over here. All you need to know is to just ignore it. Now, right here is the username. This is where our SQL injection takes place. This is poor form in SQL querying. You're supposed to be able to clean your inputs and not use concatenation like some sort of fool who would do this. This is why I'm able to hack it. And let me tell you, I'm not very good at hacking things. So, where do we start off? Well, it tells you if you type in Smith, it actually gives you something. Gives you this. That's not the answer though. That's not what we want. We want everything. We aren't satisfied with only one. We want everything. How do we do that? Well, let's just type in, say, admin right here. And of course, nothing. That doesn't really matter right now. I'm just using it as testing purposes. So, you'll notice right here, and there should be another one in here right here, but there's supposed to be a single quotes right here, and a single quotes right here. That way, anything we put in here, well, it turns into a string. Now, as I said earlier, that's bad form. You might be asking yourselves why, or you might have forgotten why I said why. So, the reason is, that's why. I can just type in a single quotes right there. And since it's not being cleaned or anything, and it's not taking out any single quotes or double quotes, that goes in, it breaks the SQL query, I can get in. So, malformed string admin, that's how we know we're getting in. And the fact that it's actually giving you these error messages means it's helping you. So that's even worse in a way. So same thing as last time, we put in our conditional statement, and we can't just do 1 equals 1 in this case, because, well, we're missing some single quotes. And the question is, where would we put them? Can't put them right there, because data type of expression is not a Boolean. Well, it's a string, so we need to have 2 strings equaling to one another. So in a case like this, let's just do test equals test. It's not working yet. That's important, because the reason why it's not working is because of this little single quotes right here is being added on at the end. And in SQL query, if you have just 2 single quotes at the end, it doesn't make sense. The SQL returns an error. Doesn't make any sense. So, since it's adding one for us, get rid of 1 quotation mark, and it works. Bam. Alright. Now, let's head on to third and final, well, testing for this demonstration. And it is pulling data from other tables. Why would you need to do this? Well, in this case, specifically, this little text field down here, it's working with essentially a table of information which is kind of useless to us. But there's this other table over here, this table to be specific, which has all the amazing, glorious nuggets of data within it. It has usernames and passwords. And that is the gold mine of any SQL injection. If you can get usernames or passwords, by all accounts, it's a rousing success. So, since we're dealing with essentially this text field which is only connected to this one table, we want the information from the other table. And this is where pulling data from other tables comes into play. Alright, so here, this little text field down here, you put in a name, you get your account information. So let's type in admin, nothing happens. We don't have access to essentially any kind of information that can give us a hint. The only information we have is the name and the information regarding the table that we want to pull from, which is user system data. It has 4 columns in it: user ID, username, password, cookie. And we know what their data types are: integer and varchars. That'll come into play later. So, how do we go about linking the two? Well, we have to do something I would like to call investigation hacking, or reconnaissance, or whatever you like to call it. So, in any case, we escape the SQL right there with a nice little single quotation mark, and we use a SQL key phrase of group by. What does group by do regarding regular SQL queries? Well, essentially you use it when you want to actually sort of group various columns by an aggregate function. I'm not going to go into too much detail regarding that, just know that it has other purposes. So in this case, we're going to be using it to find out what columns are in, well, this table we're dealing with. So, usually when you're doing group by, you usually specify the name of the column you're dealing with, or you can just do 1 to refer to the first column. And in this case, press enter, you hear the enter key, nothing. We get nothing. So you can do one of 2 things. In this instance, you can just put a single quotation marks right there and get what you want. Or you can do what I would consider probably to be better in this situation and use 2 hyphens. The reason why we want to include 2 hyphens is because there's other SQL stuff beyond what we're putting in right there. Some other SQL query, whatever. Maybe it adds some order bys or some various other things. We don't care about that. So we put in 2 hyphens, which is in SQL terms for a single line comment. So everything afterwards, it's all commented out. It doesn't matter. We don't care about it, so it's gone. I prefer that because, well, it kind of works in most situations. Now, what kind of information we get from this? We get expression not in aggregate or grouped by columns. We don't care about that. But it does specify exactly public, which is the name of the database, user data, which is the name of the table, and user ID. which is the name of one of the columns. Now, you can actually do something like this to actually group by multiple fields, but 1 and 2 is not working in this case. If we just replace that with a 2, we get the same thing. But if we do, well, what information we have, user ID, the last part changed to first name. Let's add that. It changed again. We're getting some good information here. Now, I'm going to keep on going through this, and in something that I am taking note of, and something that you would take note of if you were doing all this, you should take note of how many of these there are, their names, and their data structures of what you think they are. So CC type would probably be a varchar of some sorts. And cookie, okay. Login underscore count, that's probably an integer. And that's it. So we're dealing with a table named user data, and it has 7 columns in it, and, well, these are the specific column names, and we can infer what their data types are. So we know all that. We know the table name, and the actual stuff being called from that. This is where we actually make our attack. So let's start again with admin single quotation mark, and this is where our attack begins. So in SQL, there exists a key phrase of union. This is how we actually pull data from the other tables. This is the actual specific SQL syntax right here. A union, to be specific, does this. You have a table here, you have a table here, you want to combine them. Union is what you want to use. But there is stipulations involved, specifically 2. So you have your base table right here, and what you can only union certain things with this table. Specifically, you can only union the appropriate amount of columns and their data types. So, say you want to union a table that has 3 things in it. It has 3 columns, and it has an integer and a varchar, 2 varchars, so strings. So you can only union another table or SQL query that has 3 columns and in the correct order of integer varchars or strings. Those are the stipulations. So, and since we already know how many columns are being used and how many, well, what their data types are, at least we can infer, this is how we actually begin. So we begin with a select statement of, well, we want to use this table specifically, so, and it starts off with an integer. We only have 1 int in this table, so we have to use user ID. There's only one user ID available. There's only one integer available, which is user ID. So that is the one we have to use. Now we have 6 more to fill out, and well, we want username specifically just because it's nice to have. We want password, and then the rest, it doesn't really matter. We can go cookie, 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 and then user ID. From user system data. Right here. That's what we want. And of course, in order to make sure all this goes off, we want to use that to comment out the other stuff that doesn't matter. We hit get account information. We're in. We got everything. We got the user IDs, we got the usernames, we got the passwords, and that's all we want. So in the password right down here, we want to know Dave's password. Dave's password is password. So, you know, not exactly the most secure password, but hey, I'm being incredibly judgmental right now. Anyways, we successfully completed the assignment. We've pulled data from another table. That's good. Now, that is the actual last demonstration I'm going to show off, but there is one last SQL injection assignment within WebGoat. And it is something which I am not ashamed to say I am not, well versed enough in SQL injection to do. It looks like this, so it is something far more relatable to actual SQL injection in terms of UI. You're usually probably going to use SQL injection in a text field, probably of a username or password or register. So by all means, if you want to show that you're smarter than me in SQL injection, you can do this, and I will congratulate you, because I couldn't find solutions anywhere. Anyways, so I highly recommend using WebGoat to hone or at least learn your penetration techniques, and by all accounts, this is the end of the SQL injection demonstration. Back to the presentation. Alright, welcome back from the demonstration. Now, that was all well and good, but how do you prevent SQL injection on your website or where have you? Well, there's a myriad of solutions, and I shall describe it simply as the first one, and maybe the easiest, or the frame of mind to take into account when into preventing SQL injection is don't trust the user. Assume the user is trying to destroy your database all the time. If you go into creating security like this, you'll probably be fine. Specifically, escaping and sanitization. Essentially, this means if you find like weird characters within your text field, like, I don't know, single quotation marks, double quotation marks, the semicolon, other stuff, a lot of spaces, maybe you should, take them out. Don't allow them. Stuff like that. Now, this kind of implementation of security can be a bit buggy in some areas, so maybe not the best thing to solely rely upon escaping and sanitization. The point is trying to make is to essentially not give the user a single chance in trying to wreck your database. Second one is pattern checking. Kind of similar to escaping and sanitization, but in a case of, well, say you need to put in an email address. You should probably have an @ symbol in there somewhere. And it should follow something@something.com. So regular expressions can also work in this case. That prevents SQL injection. Third, database permissions. You should not allow like some insane username and password in a case like that, the user has to essentially kind of create a SQL query in a way in order to query the database. The user should not have permissions that admins should. They should not be able to allow access to certain parts of the database of, like, say, financials or whatever. Something to take into account. And using prepared statements. One of the easiest things to do is to essentially not allow the user to craft SQL statements in any ways at all. So using prepared statements is one way. If you're searching for someone in a directory, make it so that it's not actually putting together SQL queries, but kind of just running predefined stuff already, which is, well, probably one of the easiest things to do. The point is trying to avoid dynamic querying, which essentially allows for SQL injection. Anyways, now that's pretty much the end of SQL injection. It's been around forever, surprisingly still a problem since forever, and hopefully I've done something to educate you, provide you some knowledge, in order to better, I would say, protect yourself against, well, one of the most laughably easy cybersecurity things out there. Anyways, my name has been Taylor Johnson. Thank you for listening to me, and for sharing you my presentation.